Hi there. I wanted to take a few minutes and do another example with an axis shift. So here, an example two, and I want to kind of try to explain how I get that radius, that different radius on these using the cylindrical shell method. Um, I'm going to look at finding the volume generated by rotating y equals the square root of x equal to 2y all around the x equals 5 axis. And so what I'm going to do is I'm going to go ahead and start by finding my points of intersection. So points of intersection so that I can draw this. There we go. I'm going to set, here you'll notice that I have this y1, y is equal to the square root of x, or I have this x is equal to 2y. What I'm going to do, since I know I'm doing cylindrical shells, so let's draw just a little bit first to try and see what's going on here. Okay, I'm going to have my axes, right? I'm going to be going around x equals 5, 1, 2, 3, 4, and 5. So I'm going to be going around this line. This is x equal to 5, and I'm going to be going around that. So if I'm looking at a cylindrical shell, which is what I'm going to use for this one, just to draw one in before I even have a graph, which axis am I going through? I'm cutting through the x-axis, right? So I'm going to want to get to the point that I have v is equal to the integral from a to b of a of x dx, because I'm cutting through the x-axis. So that kind of helps me figure out which way I should solve these and which one I should solve for what. So if I want everything in terms of x, I'm going to go ahead and solve this second equation here so that I have a y equals. So I'm going to say, first of all, I know that y then equals 1/2 x, right? And we're going to go ahead and find our points of intersection. So if I have y equal to y, then I have the square root of x is equal to 1/2 x. I'm going to square both sides. So I'm going to have an x is equal to a 1/4 x squared. That's going to give me, I'm going to multiply the 4 across. 4x is equal to an x squared. Move everything to one side. I get a 0 is equal to an x squared minus 4x. And if I factor out an x, I'm going to get an x minus 4. And so I should get x values of x equals, whoopsie, there's a lot of equal signs there. Let's stop. I get x equals 0 or x equals 4 for my points. All right, so I know I have points of intersection at x equals 0 and x equals 4. I'm going to use the second equation to find what my y values are there. And so at x equals 0, I'm going to have a point right here as 0, 0. Right, so I have 1 point at 0, 0. And then when x equals 4, I get a y value of 2, so I get a point at 4, 2. Alrighty, so 4, and I'll make 2 going up, 1 and a 2. This is 2. And so at 4, 2, right about here. All right. Okay, well, points of intersection are done. What I need to do is now graph it. So if I look, that y equals 1/2 x, that one's a nice straight line. So I'm just going to go ahead and pop that in. I'm going to do that one. Let's do it in blue. So this is my, right here, this is y equals 1/2 x. And then if I look at the y equals the square root of x, let's see, let's say that x equaled 1. So for that one, at x equals 1, y equal to the square root of 1 is going to be a 1. So I'm going to have a point of 1, 1 for this function. And so I'm going to have something that looks like this. Alrighty. So if I zoom in a bit, let me color it in. This is what I'm rotating. Again, I'm rotating around this x equals 5. All right. So if I come over here, I'm going to move my volume kind of down below it. And let's label a little bit. This is my y equals square root of x, right? I'm going to have on the other side over here, so I'm going to move my axis a tad. I'm going to have, let's go 1, 2, 3, 4, and 5. So this is 10. If I look, I had a point right here. This is the mirror image of this point right here. Okay. I have another point over here. It's 5 over and on the axis, so I have a point over here. I'm going to go ahead and draw the line and my little curve. That's a really little curve. There we go. All right. So we kind of can see what the rotation looks like, and I'm going to draw in my cylinder. And again, if we look at this, let me see if I can get it in the right place. If we look at this cylinder, oh, I totally missed. If we look at the cylinder, there we go. We can see that if I were to draw an inner thickness on it, just like make it have just a little itty bitty tiny thickness, that this definitely would be a dx, right? And again, I'm cutting through the x-axis, so this kind of reinforces that my volume needs to be in terms of x, or my area needs to be in terms of x. Let me fix that. All right, so first things first, let's draw this cylinder pulled out. Let's try it again. I'm having trouble with cylinders today, really. All right, this is the way I usually do the height first. All right, so obviously a little taller than what I wanted. Let's start with the radius, all right? Let me find a color I haven't used. So the radius is going to go from here to here, all right? So here's how I'm going to explain it this time. I'm going to say from here to here, that distance right there is 5, right? The distance right here from here to here, that's x, whatever my x value is right there, okay? And so I know that my radius is going to be equal to a 5 minus x, because that's what this distance right here is, all right? So I'm going to have a 5 minus x. I hope that makes sense to you, all right? If you need to, watch it again. If you want me to move things, and let me do this a little bit and show you again. Move it up a tad for you. So what I'm doing is I'm saying that my distance from here, from this line, all the way over to the y-axis, that's 5. My distance from here to the y-axis is x, right? Because that's my x distance. That means that my distance from here to here, just in this little interval, is 5 minus x. That makes sense, because if I add those together, then they're going to add up, right? All right, so that's my radius. My height here, that's going to be whatever this height right here is. So I need to do top minus bottom. So usually I put h over here, but I'm going to say h is equal to, again, top minus bottom. I ran out of room. And so I'm going to say that h is equal to, my top curve is that square root curve, the square root of x. Again, I wanted my area in terms of x, so this is good. Minus my bottom curve, which is 1/2 x. All right. All right, so let's write out our area now. So I'm going to get that a of x is equal to 2 pi rh. That means it's equal to 2 pi times my 5 minus x times my square root of x minus 1/2 x. Now I'm going to go ahead and FOIL that just so that it looks better. So I'm going to get a 2 pi times a 5x to the 1/2. I'm changing that square root into 1/2. And I'm going to need to move this all over a little bit. So let's move over a tad. There we go. 5 to the 1/2, or 5x to the 1/2 minus a 5 halves x, that's my outers, minus an x to the 3 halves, that's my x times my square root of x, plus a 1/2 x squared. Okay? So at this point in time, beautiful, beautiful area there. At this point in time, we're just going to sub in. And so I'm going to have the integral. I'm going to actually pop the 2 pi out front. 2 pi times my integral. The rest of the area is a 5x to the 1/2 minus a 5 halves x minus an x to the 3/2 plus a 1/2 x squared. All of this dx. All right, limits of integration. Again, these are in terms of x because these have to match this dx. So I know I'm looking at x terms. Again, I'm only looking over here on this side, only the shaded region for my limits of integration. So I'm going to go from x equals 0 all the way up to x equals 4. So I'm going to integrate from 0 to 4. From there, I think you can handle it. I can just integrate each term separately. I'm not going to sub in, I don't think, 2 pi times what I should get is a 5. Hold on. Let's back up. Oh, okay. That was a little further than I wanted to. I'm going to get a 5 times my x to the 3/2 with a 2/3 out front minus a 5 halves x squared over 2. That's my second integral minus an x to the 5/2 with a 2/5 out front plus my 1/2 times an x cubed over 3. And you can see that this has an awful lot of fractions in it. And I'm going to evaluate that from 0 to 4. So from there, I trust that you can get your answers. You're just subbing in at that point in time. I would clean it up and sub in. So take a look at that. I trust that you can finish the problem. But I wanted to talk about the axis shift a little bit there, just so that you could see it a little bit better. I'm going to do another one with a y-axis shift, just so you can kind of see that one. Maybe redo the problem below or one of the other ones. Again, with cylindrical shells, just so you can see kind of what's happening there. So I hope this helps. And again, if you have any questions, let me know. Thanks.